Cheap Air Gunner channel, Cherokee Steve. Thanks for coming back. What we're going to be getting into now is the actual modifications that are going to help increase the velocity of our 1322. Now, before I get into the valve, which is the biggest contributor to increasing the modifications made to it into increasing the velocity of this 1322. A couple of things I worked on off camera, and I apologize. This isn't something I recommend doing at home. You certainly can try. First, let me get to the first one, and that's basically what I'm going to have here is a hammer spring pre-tensioner or a power adjuster, whichever you want to refer to it as. But the plug that goes into the end, the hammer end of the pump tube, I have a drill press in my garage with a 4-inch vise. So you really need something to adequately hold the plug, which the vise allows me to do, which I know a lot of people aren't going to have. But you use a, I can't remember the exact designation for the drill, but it's 0.201 diameter drill, which is what you need for the minor diameter of a 1/4" 20 thread. And obviously you need a 1/4" 20 tap, but you hold on to the plug, and then in the vise, and as centered as possible, you feed the 201 diameter drill through, followed by hand tapping with a 1/4" 20 tap. And the point for that is what I've done, the power adjuster I put on my 2289. You can get these knobs with 1/4" 20 thread on eBay. Basically what these are for, on a motorcycle, especially like the Harley Davidson Sportster that I used to have, the back portion of the seat attached to the rear fender with one of these knobs. It basically lets you unscrew and quickly change out the seat from a single seat to a double seat, or as an example. But these little knobs come in all different styles, very cool looking, very I like the way that they look, and they're only, I think, about $5 a piece on eBay. But the common thread that's used in that application is a 1/4" 20. So that's what's on this end of this. So I have a 1/4" 20 nut, which I screw on here as far as it'll go. This screws into the plug. The hammer spring is going to go in the 1/4" 20 threaded screw section of this knob is large enough so it's not going to go into the inside diameter of the spring. It's actually going to push against the spring. And simply by screwing it in or backing it out, you can adjust the pressure, the pre-cocked pressure on the hammer spring. And of course, after it's cocked, you'll have, depending on how much pressure you put on, a more bound up spring, which is ready to explode, release at a higher pressure, pressing the hammer forward with more force. Now, a lot of people just use a heavier hammer spring. The 2289 modifications that I made to my backpacker, I reused the stock hammer spring. I really think it's adequate the way that it is. It's a pretty thick diameter coil. And a good overall length. So I'm getting about 0.35 to 0.40 diameter wire that's used. Good overall length allows for adjustments to be made if you do have a power adjuster without binding up. So that's something that I will be reusing in the exact same spot that it was used in the stock 1322. The hammer spring is exactly the same. But then we have, this is going to be the power adjuster on the end. Then you just, wherever you find is the tension you want, obviously at that particular point, while holding the knob itself, you screw in the nut and tighten down the nut to hold its position. The other thing I did, I just thought it aesthetically looked good, was I polished the outside of the plug itself. So that is no longer black, but a polished silver color. So that is something I definitely consider to be a power modification. Again, if you don't have something like a drill press, 1/4 inch 20 tap, a 201 diameter drill, 4-inch vise drill press, you can get away with finding yourself a heavier hammer spring, and that will work for increasing the striking force of the hammer against the valve. The other thing I did, which I'm going to be replacing that roll pin, although I do want to say this, after having seen the type of roll pin and the improvement in the roll pin that Crossman has made, it certainly is a much stronger replacement to what they used to use, but I still like to use a solid pin at the pump handle pivot position. And basically what I've done is taken a 3/16 drill, broken off the fluted section of the drill, so I've got just the shank left. I have a bench grinder, and with the bench grinder took this down to an overall length just a little bit under 1 inch in length. What that gives me is a really nice fitting solid pin through this end of the pump tube. As you can see, it just barely hangs out. I think it's a nice clean look. There are lots of aftermarket replacements for the roll pin. The more you get to disassembling your gun on a more regular basis, whether it's to periodically do maintenance or do modifications in steps. I can get to this right now, don't have the time to do everything. I'm going to have to disassemble the gun later on. Something that quickly and easily is removable at this pump handle pivot location. That roll pin can be somewhat of a headache as far as removing and reattaching multiple times. What I have on each end of this, what is now a solid pin, like I said, this is just the shank portion of a drill, but you can take a Dremel attachment with a cutoff wheel like this one and just go around. Now, one of the things that aids in cutting a notch at each end of this pin is chucking this up in a drill and having it spin in one direction while your cutting wheel is going in the other direction. And you get a nice even width and depth to your slot. But what that slot is for, I use in the O-ring set that I have that I showed before that was purchased from Harbor Freight. The smallest size O-ring that's in that set is a really nice tight fit over the end of the pin. So you stretch it over the end of the pin and it falls into the slot. Wrong end. Feed it through the hole that the roll pin used to go through. The O-ring keeps it from going further, but as you can see, my pin with the notch is sticking out the other side. Another O-ring goes on this side. The O-ring keeps the pin from falling out. There's going to be pressure from the pump handle and the piston itself putting pressure against this. It's a not a sloppy fit, but yet easily slides back and forth. But that's what I'm going to be using in place of that roll pin. Some people will go about this and use a C-clip on the ends rather than the O-rings. I think the black O-rings are a nice clean look and matches the rest of the gun. That's the only reason why I prefer those. It's mainly aesthetics. Clips will work. There's plenty, if you can't do this or don't feel comfortable doing this yourself, plenty of aftermarket upgrades for this pins. There's one thing I will mention. On my backpacker, my 2289, there was a stainless steel pin that had screws that screwed in. The heads were just a little bit larger than the pin itself, and it was the screws being screwed in on each end that kept the pin from falling out side to side. Stainless steel is actually a very soft metal. And what I found the hard way after putting everything back together, after modifying my 2289, the repeated exercise of using multiple pumps, well over 10 pumps, you know, 30 to 40 pumps, eventually bent that pin. And after I thought about it, I really shouldn't have been surprised that it did, because of how soft stainless steel is. Then you put a hole on each end of it. You're hollowing out each end, which is right where it's going to be, the pressure of the pumping is going to press this pin against the tube itself. Well, if you hollow that out and thread it for a screw to go in the end, that's a good weak point to that particular setup. So, in the case of building a gun where you're going for power and you're going to be going well over 10 pumps repeatedly, I would not recommend a stainless steel pin in this particular instance. And as I said, that's something I've just learned on my own the hard way. So this is what I'm going to be using for the pump handle. This is not a power upgrade. It certainly is necessary, in my opinion. As you increase the power of the gun, you increase the number of pumps you're going to make, you're going to have to reinforce certain parts of the gun and strengthen certain parts of the gun. There'll be other things that will have to be reinforced better than it was in a stock condition, but this is one of the things that is also going to have to be upgraded from that roll pin. So with all of that said, let's get on to modifying the valve. Okay, modifying the valve. We already did the video with the disassembly of the valve, and I'm going to start off with the modification with the most difficult aspect of it. We have our two halves of our valve housing. The one with the cone-shaped end, the other one that the valve pin goes through, the pin that gets struck by the hammer. Those two halves. We've got the valve pin with the poppet on the end. We've got the checked valve. We've got the hammer spring. Not the hammer spring, excuse me, the valve spring. Now, without having to do any modification, any grinding, any polishing of anything, first thing we're going to do is get rid of this valve spring. It's just too tight. We don't need something that is this thick and this hard to compress. In my spring kit that I bought from Harbor Freight, I have this one. It's a much thinner wire, coiled wire than this one. It's a little bit larger in diameter, not too much, not too bad, and it's very easily compressed. Now, that is our first modification. Replace the stock valve spring with something that is similar but easily compressed, thinner in wire gauge. Again, this is going to take up less space because of the thinner wire than this. And the less space the spring takes up, that space can be filled with air. That's the reasoning behind everything we're going to be doing to all the different valve parts. So first thing, without having to do any type of grinding, is just change out the spring. That's easy. Now, I like to start with the half of the valve that has the cone-shaped end. It has male threads on the opposite end. It has about 6 threads total, and we don't need those 6 threads. We only need 3. So, what you're going to do is cut a piece of masking tape, wrap it around, not the first 3 threads, but the last 3 threads, and try to get it nice and straight, nice and even, because what we're going to do is use our cutoff wheel with our Dremel tool and follow that tape. We're going to go through just so that it goes through the surface of the threads, and then work our way around, trying to stay as even with the tape as possible so we get a nice straight cut. Okay? Now that we got that ready to go, now the tape doesn't have to be stuck to the threaded area itself. Just make sure that the edge of the tape is nice and straight all the way around, because it's just going to be a guide. We just want to follow the edge of that tape with the cutoff wheel. I've got the 3 threads cut off. I've only got 3 threads cut off, 3 threads remaining. You could flat sand the edge of this, get it nice and smooth and level and even all the way around. But those 3 threads that we got rid of used to take up space inside this half of the valve, and now it's not going to take up space. That's going to be replaced with air. So we've already increased the volume of air that can be contained inside the valve. Now the next part of working on this, we're going to remove our cutoff wheel. When you're doing this, make sure you're in a you're in a place that you don't mind. There's going to be a lot of aluminum fragments flying off. Should probably wear a mask to avoid breathing any of it. But definitely you're going to have to, don't do it in close proximity to any gun parts you have, because you're going to get aluminum, really small aluminum chips all over everything. So someplace away from the gun parts that can easily be cleaned up when everything is said and done. The next thing we're going to do, I have a bunch, not a bunch, I have a variety of different grinding bits, stones. This one's larger. I've done some modification to it with a sharpening stone. This one is narrow. This one is a little bit shorter, but a little bit wider than this one. And it's going to be a combination of those three. We're going to go in and grind material out of the inside of this. Now you want to stay comfortably away from the bottom of the bottom of the inside of the valve. Now this particular, and this is, you know, the surface that the check valve is going to be seating against. You definitely want to stay away from that. And what I like to do is take a Sharpie I've got a red one here. What I'll do is actually put the grinding wheel inside. I've got to do some more shaping to this, but put it inside the valve and mark on the shaft a point that is well, you know, if I go into that mark, then I'm going to use the Sharpie, that I know I'm going to be well short of that seating face that the check valve goes against. Better example, I'll use one of the other stone grinding bits that I have. So if I go in here and I'm touching that face right there. I'm going to mark the shaft of my tool with my Sharpie. I'm actually going to go up a little bit to be extra careful. And now I know as I go inside and I grind away aluminum from the inside of this valve, I want to stay short of that red mark I just put on there. But this is how it's going to work. I'm just going to work this over and over, back and forth. It's going to take a while. The larger the grinding stone you can get in there, the better. Like I said, I'm going to have to take a sharpening stone and take some material off of here so I can get this one in there. For the time being, I'll start off with this one. As the stone starts to get caked up with aluminum, it's good to have a sharpening stone anyway to clean that gummed up aluminum off of the grinding tool itself. So a sharpening stone is a good thing to have. Again, this is going to cause a lot of aluminum chips. We're going to want to stop often and clean up the inside of the valve itself, but it's going to take a while. But it's just a matter of patience in grinding, cleaning, grinding, cleaning, and not going in too far. Once we have this side of the valve done, we're going to move to the other side of the valve and do the same thing. Now we have female threads on the inside of here, and there's quite a few, and we don't need the amount that's in here. So what I like to do is start my tool in. We want to leave 2 to 3 female threads in here. We can take down the diameter of this half of the tube to the point where the threads that are farther in than, let's say, 3 threads in are completely removed, and approximately that amount of material can come off the entire inside. Again, we want to stay well short of the surface that the valve pin and poppet go seal against. It has a sealing surface on this side. We do not want to hit it. We want to mark our tool the same way and work in and grind away material from the inside of this half of the valve. I don't know if you could see inside of there, but I've left 2 to 3 threads. Now we want to make sure that everything still engages cleanly, screws on freely. It does. So we've got a lot of material removed from the inside of the valve. That is going to be now an increased capacity for air. The next thing we're going to get to is the check valve and the valve pin and poppet. Actually, before we get to the check valve and the pin with the poppet, what I'm going to do is on the side of the valve with the female threads, that's also the exit port for the valve. What I have, and if you've got a good selection of tools for your Dremel tool, this is a metal bit, very thin. What we're going to want to do is, because of the right angle, this is a hole, that port is just going straight up. The portion of the port down towards the bottom, we want to grind away on an angle. I'm exaggerating here. We want to avoid hitting other areas of this port. Just make a smoother transition from the inside. Instead of the air having to come outside the valve and straight up, we want it to kind of flow on a curve or an angle, just to make it more efficient. But this is the type of bit you're going to want to use. You want to be careful working your way down on an angle and trying to only remove down towards the bottom. Don't freak out too much. If you do happen to hit other areas of the port, the seal on the end of the transfer port is large enough that as long as it covers up any nicks or any areas you may hit by mistake, it'll still seal off the opening in the valve itself. That's the point of the rubber gasket slash seal on the end of this end of the transfer port that sits on top of here. This is going to be hard to see, but number one, I do have it angled down towards the bottom where I wanted. I have hit the back portion of this port and the sides of the port. So I'm just as likely to screw up as anybody. God knows I am not perfect in any shape, way, or form. But I'm not freaking out. As I said, even though I did hit with the shank of my tool and remove some material off of areas of this port opening that I did not want to remove material from, when I double check it with my transfer port and the seal from the transfer port sitting on top, when everything is assembled and this has pressure on it from the barrel port pressing down on the transfer port, everything should be sealed off okay. Definitely looks that way to me anyway. Now some people in this instance make a replacement transfer port out of refrigerator water line tubing. I prefer to use the stock transfer port, the solid transfer port, and modify the inside diameter of it, but we'll get to that later. This seems to be okay. So we're pretty much done with the valve housing, grinding and modifying. Now we'll move on to the valve pin slash poppet and the check valve. It's really hard for me to communicate the amount of time this is taking. The grinding process is slow and tedious, and a lot of the vast majority of this has been edited out simply for time's sake. But I just want to stress, take your time, work your tool in a way hopefully that you can see exactly where it's going. It's going to be really hard. The inside of that transfer port is fairly small. Take your time. Do not hit the bottom ends of either half of the valve housing. And whatever material you can get removed is a bonus, okay? Any material you can get removed is going to be replaced with air being inside that valve. So doesn't matter how minimal amount of the material is that you take off, it's still going to be a increase in air, which will lead to an increase in velocity. So just remember that. Take your time, be careful. Certainly be safe. So moving on, we are going to start working on the valve pin and valve poppet. What I suggest is you chuck the end of the pin up into a drill with a small stone attachment. One of the things we're going to do is take down some material approximately 400 thousandths, a little bit under a half an inch, back from the back end of the poppet. We're going to try to grind a nice sweep on the pin itself. Obviously, we don't want to take too much off. The striking force of the hammer against the pin, we certainly don't want anything to crack and break as far as the pin goes. So we still want to, it's just a very small amount of material so that when the hammer does strike the back end of the pin, it forces it forward. That ground out area is going to hopefully be close to or even with the port area on this particular half of the valve. It just makes for a more efficient, it's going to open up the opening leading into the port instead of being completely blocked off by the pin, and just allow for more efficient transfer of the air stored in the valve up into the transfer port. So you really don't have to take off too much, but that's what we're going to do, along with the sharp edges that are on the poppet itself. Again, we're going to stay away from the back side, that's the sealing side of the poppet, but the smaller diameter that sticks out, we're going to round off the edge of it. And even if you want to take some material off that particular face of it, you can do that as well. Again, this is just going to create more space inside the valve to be taken up by air rather than the material that the poppet itself is made out of. Again, more air equals more power, higher velocity. Okay? Be careful not to put too much pressure on the poppet. We don't want to melt the material. We simply want to remove it. So be careful when doing that. Spin your drill. Be very careful working around the edges. It really doesn't take very much. If you want to polish up the pin, you certainly can. Again, avoiding any contact with the back end of the poppet. I'm just smoothing it out with some Scotch-Brite. Red is fine grain of Scotch-Brite pad. I'm going to try to get this up close. You may be able to see the area where I went down with the stone on the pin itself. And then the squared off end, I beveled. And I actually beveled just a tiny bit of material off of this end, the wider diameter. You want to stay completely away from this backside. That concludes the modification to the pin and the poppet. Now the next one is really easy. This is the check valve. Now remember, I double checked with my parts diagram to make sure I had the loading direction of the check valve correctly. And the way that it goes is with the tapered, the end with the taper on it goes, take the half of the valve with the outside tapered end, and that tapered end on the check valve goes in facing the outside tapered. The flat end faces the inside of the valve. So that flat end, all I'm going to be doing is taking a very small drill bit. Let me get a decent size. Definitely want to, I would stay under 1/8 of an inch. 125 diameter is getting really close to the outside of this boss area. Too close for my liking. So I'm going to pick something smaller, roughly closer to 0.90 in diameter. I've got my drill bit. It's with my calipers, it checks about 0.87 in diameter. Basically what we're going to be doing on that flat boss side of the check valve, the side that's going to be facing the inside of the valve, I'm going to, as best I can, center the drill to that side of the check valve. We're going to drill a hole approximately halfway through the check valve. If you need a piece of tape to mark that on your drill so you don't go too far, you can do that. I got a pretty good idea here of how far I need to go. Keep a pretty firm grip on there. Keep constant pressure so that it doesn't sit in one spot and again heat up and start to melt the material. But I'm trying to get this in decent view. There's a small hole in the end. Not all the way through, obviously. We don't want to go all the way through, about halfway deep. Again, this is removing material that will now be taken up with air. Remember, remove material, replace with air equals more power, more velocity. So, what we've been able to finish up here is removing quite a bit of material, removing threads, male threads, from the one half. Got the material removed from both halves of our valve housing, including half of the male threads on the one half. Internally, we've removed material. We're going to be replacing the spring, the stock spring, with a thinner gauge wired spring. We've drilled a hole in the end of our check valve. We put a little spot of clearance on the pin itself, on the valve pin, and beveled the end of the poppet. All of that is going to open up what was taken up by material, open up that space, and now that will be taken up with air. Put the check valve in. Make sure it's facing the right way. That drilled hole now is that's got to be facing the inside of the valve. Spring. Pin and poppet through the inside portion of the other half of the valve so that the pin is sticking out. Compress the spring and start to turn. You really start to notice when it starts to make contact with the O-ring. Now, one of the issues that commonly happens is when these two halves are screwed back together. On opposite sides, this is the port, the outlet port for the valve. So that's going to be facing up. That's going to be in the gun like this. On the bottom is going to be the threaded hole that the screw that's just in front of the trigger guard screws into and helps stabilize the valve. Now these have to be pretty much exactly 180 degrees opposite of each other. Now a lot of the times when you go to tighten this, they end up not being 180 degrees. Now in this particular case, I've hand tightened it, and the way that it's off, this threaded hole down here, I'm going to exaggerate, but it's over here. So as this gets tightened down a little bit more, that's going to rotate it back down this way, which is the direction it needs to go. But it obviously needs to be tighter than hand tight, because the two holes are not lining up with each other when I'm doing it just hand tight. So this is going to involve bringing back out the channel locks, getting a better grip on the outside surfaces of each half. And let's see if getting a little bit more of a turn using the channel locks will get me those two holes 180 degrees from each other. It looks pretty close. If anything, it's probably gone a little bit too far. It's really hard to match up. I'm going to use the wooden end of a toothpick. That's pretty good. So, they do seem to be 180 degrees from each other. That little extra tightening procedure with the channel locks helped. Now, one of the things I just did, having needed to get the grip that I needed to get on there, I did mark up the outside of the valve. So I'm going to go back. Again, this isn't really critical, but I am the type of OCD type personality where personally I just want a nice finish on the outside of the valve. No raised material. Be careful not to squeeze it. Now remember, the walls on that valve are going to be thinner since we removed the material from the inside. So when you go to squeeze it, as I just did, to get those the port hole 180 degrees opposite of the screw support hole, you don't want to be squeezing it to the point where you're crushing the valve. And actually this particular raised gouge that I put into it, it's really tearing up my felt polishing wheel. So I'm going to actually move on to using a small piece of sandpaper. Or actually, in conjunction with the Scotch-Brite I was just using, I will polish it. The final thing I'll do is polish it. But another good thing to pick up that I have a few of are these needle files. Very small, very thin. This raised section of material, I put a decent gouge in the material with those channel locks. I'm just going to, it's aluminum, not going to take much. File that away. What's a good idea in this situation is to get yourself a small piece of tissue, or in my case I've got some paper towel here. A very small piece, and especially the this port, that the port side, the port hole. Let's plug that up, because now when I go to polish it, any of that aluminum dust I don't want getting into the valve. So I'm going to plug that up and come back with my Scotch-Brite and polish that up by hand. Okay. Want to wipe that down, get all that dust off of there. Okay, that's better. It's smooth, no raised material. Yeah, it got scratches on the outside, but when it's going to, hopefully, it'll perform its function the way that it should, and it's not going to be seen because it's going to be inside the pump tube. So it's not that big of a deal. But one of the things you'll notice is now that it's all reassembled, the amount of pressure it takes to press this pin in. Number one, it's returning back nicely. The amount of pressure it takes to press that pin is a lot less than it took with that stock valve spring, that heavy spring. So not only is it going to take up that thinner gauge wire, that the spring that's currently inside there, not only is it going to take up less space and allow more air to go inside, but it's going to allow this valve to stay open longer as it's struck by the hammer, because it's going to be forced in farther, allowing hopefully a full dump of air. Hopefully the maximum amount of air I can pump and fit into this valve will all come out with one hit of the hammer and be 100% behind the pellet, propelling it down the barrel. Okay? So, with the exception of the O-ring that needs to go on the outside beveled end of the valve, we're done with the valve. Here's that O-ring that goes on the outside. Back in its groove. A light coating of some silicone oil wouldn't hurt on that. I'm going to post a picture at this point in the video. It shows the valve and the internal parts, and what you'll notice is in the gray, what's colored gray in the picture in regards to the parts, including the inside of the valve housing, that's the areas where we want to remove material. Picture probably can't explain everything much better than I have in words, so let me do that right now. Okay, hopefully that picture will be of help. I know it was for me. But that pretty much concludes our valve modification portion. Um, the next video I'll be doing will be going into basically the two last things we need to be removing material from. Those two things are the transfer port, which allows the air to be transferred from the valve to the barrel. We're going to be opening up the inner diameter of this particular piece, the transfer port, and we're going to be opening up the diameter of the barrel port. We don't want to choke off at this point. There's, to have done all the modifications that we have, only to have smaller than optimum openings in the transfer port in the barrel itself. There's no point in choking off that increased air that we've gotten into the valve. So we want to open those up, and we'll get to that in the next video. Thanks for checking this one out. Stay safe and shoot safe. Take care.